Hi class, this is Dr. Karsten, and today we are doing lesson 16, and this is from module 5 in grade 4, and it's EngageNY Math. So today's lesson is a little different, and I'm kind of excited that we're moving away from some of the other things and we're moving into adding and subtracting fractions. So today's lesson is actually going to be kind of an easy, fun one, and I think you guys are going to do great with it. So let's start with the concept that I've been really pushing with you, which is that if I am if I am looking at fractions, and we did this a lot when we were taking a fraction greater than 1, we would pull out 1, and I kind of used this language with you before, where I explained that the number in the denominator, while it's telling us really the size of each piece or each fractional unit, it's also kind of just a label. So let's kind of look at labels for a second. Let's say that I have 5 ones, so that's like 5, minus 4 ones. How many ones would I have left? Well, 5 minus 4 is 1, so I'd have 1, 1. Let's say that I had 5 apples, and I subtracted 4 apples. How many apples would I have left? 1 apple, and I know you guys get that. If I had 5 dogs and I subtracted 4 dogs from that, I'd have 1 dog. If I had 5 meters and I subtracted 4 meters, I'd have 1 meter. Well, really similarly, if I had 5 sixths and I subtracted 4 sixths from that, I would be left with 1 sixth. So here we've just kind of changed what our label is. And again, I could write 5 sixths like this, minus 4 sixths is equal to 1 sixth. And make that a little bigger. So again, this becomes a label for us. And that's really, it's a label with information. It tells us how big each piece is, each part, each fractional piece. But it really can be seen as a label. So I can say that I have 5 of this size pieces minus 4 of those pieces gives me 1 of those pieces. And that's really how we've been talking about it a lot when we were dealing with fractions greater than 1, and we wanted to turn them into a mixed number. So 5 of those size pieces minus 4 of those pieces gives me 1 of those pieces. Let's see if we can maybe model that with a number line. So I'm going to go ahead and do a quick sketch of a number line for us. So we need our 0, we need our 1, and then since this is our denominator is 6, the number in the bottom is the denominator, it tells us the number of pieces that I need in here. So I need to turn this into 6. There we go. So let's see if I have 6 pieces. 1, 2, 3, 4, 5, 6. So all these together, one whole, just as a reminder, would be 6 sixths. And I like to really emphasize that with you. Similarly, 0 would just be 0 sixths. And I really like to emphasize that and make sure that you guys are clear on that. So now let's figure out where 5 sixths is. I'm going to go 1, 2, 3, 4, 5. And I always like to do it like that and hop. All right, so I have 5 sixths. And now what we want to do is we want to subtract 4 sixths. Now, some people like to count backwards, and they'd be like 4, 3, 2, 1. But my preference is that I like to count the 4 sixths. I want to show that I'm going to the left. When we subtract, we're going to the left on the number line. And I like to just count all the sixths going up. So I'm going to go, I went back 1 sixth, I subtract 2 sixths, 3 sixths, 4 sixths. And I always talk about hops. You can't count it until you've done the hop. So I can't, from here I've gone back 0 sixths. So I'm going to go 1 hop, 2 hops, 3 hops, 4 hops. And that seems to help people a lot. And if I do that, I now have 1 sixth, just like we showed up here. Now, to model this, what I have to do is I need to make one arrow, and I didn't really leave myself a lot of room, but it's actually right here. I would want to show what happened here, that I subtracted 4 sixths. I'm sorry, that's kind of like a lame 4, but it says minus 4 sixths. So 5 sixths minus 4 sixths gives us 1 sixth. So let's do one more of these just to make sure that this is making sense for you. So let's model, let's do 7/8 minus 3/8. Okay, so I have 7/8 minus 3/8. So again, this is just telling us the size of each piece. So I have 7 of these pieces minus 3 of those pieces will give me 4 of those pieces. Because 7 minus 3 is 4, so it's 7/8 minus 3/8 is 4/8. And now let's model that on a number line. I'm going to leave myself a little bit more room this time. So I have a 0 down here, I have a 1 up here, but now I need to break it up into eighths. So let me go ahead and do that the best that I can. And we want to try and get them even as we can. Okay, so again, this would be 8/8, this is 0/8. Let's figure out where 7/8 would fall. And let's double check and make sure we have eighths. 1, 2, 3, 4, 5, 6, 7, 8. Yep, we are good. So let's find 7/8. 1, 2, 3/8, 4/8, 5/8, 6/8, 7/8. So that's where 7/8 falls. And now from 7/8 we need to subtract 3/8. So I'm going to go back 3/8. So 1/8, 2/8, 3/8. Or again, if you wanted to go, you could go 3, 2, 1. But I prefer counting up. And that's going to, let's see where that leaves me. 1, 2, 3, 4. So that leaves me at 4/8, just like we said. And now I need to model that by showing that we subtracted 3/8. Our arrow shows the way we're going. We can say we subtracted 3/8. We're good. Okay, so now we modeled that twice. So now let's do something a little different. I know that I mentioned in the beginning that we are also going to be working with fractions greater than 1. So let's model this with one where we are going to end up with a fraction greater than 1 so that you know what to do with that. So let's try 10/6 minus 2/6. So if I have 10/6 minus 2/6, again, this is the size of the piece, so I'm saying 10 of these pieces minus 2 of those pieces leaves me, well, 10 minus 2 is 8. So that would leave me 8 of those sized pieces, 8/6. As you can see, my numerator is larger than my denominator, which makes this a fraction greater than 1. And what I want to do with this 8/6, I'm gonna pull it over here for a second. What I want to do is I want to pull out any whole pieces. I want to take out part of that. Well, these are all sixths, and I know that 6/6 is the same thing as 1 whole. So whatever your denominator is, you're going to want to pull out that many pieces from your numerator. So what does that leave me? Well, 8 of this size pieces minus 6 of them leaves me with 2 of them, or 8/6 minus 6/6 is 2/6. And now what I can do is I can take this 6/6 and I can say, well, 6/6 is just 1. So I have 1, and then I still have my 2/6. And that's modeling taking this fraction greater than 1 and turning it into a mixed number. So this would be my answer right there, 1 and 2/6. All right, let's do another one. I just wanted to see, did I do that? Yeah, let's do, no, you know what? I think we're good with these. So let's do addition. I just had a whole bunch of problems jotted down for myself, so let's jump into some addition now. So addition we're going to do just the same way. Let's go back to this idea of if I had 1 apple and I added to that 4 apples, how many apples would I have? So 1 apple plus 4 apples would give me, oh, I'm all crooked, would give me 5 apples. This is just the inverse of the problem that we started off with before. It's very similar. So now, because watch what we're going to do, we're going to say if I have 1/6 plus 4/6, that's going to leave me with 5/6. 1 of this size pieces plus 4 of those pieces gives me 5 pieces. So that is just the inverse of what we did earlier, where we did the subtraction. And I have no idea where I just put that piece of paper. Oh, here. So where we modeled it. So as you can see, we went ahead before and we did 5/6 minus 4/6 is 1/6. Now what we have is 1/6 plus 4/6 is 5/6. It's just the inverse. So let's go ahead and model this on a number line. And again, I didn't leave enough room on top. I'm sorry. So again, I'm doing 6. So I'm going to have 0, I'm going to have 1, and then I need to have 6 equally sized pieces in between. So I'm going to do my best to try and make them equal. So let's see, I have 1, 2, 3, 4, 5, 6. So let's see where we're starting on this one. For this one, we're starting at 1/6. And then we're going to increase or go up 4/6. Then again, I like to think of my hops. So I'm going to do 4 hops. 1 hop, 2 hops, 3 hops, 4 hops. And that's going to put me here. So oops, I forgot to label 1/6. So let's see. 1, 2, 3, 4, 5. And look at that, it worked. So we started at 1/6. We went up, we increased by 4/6 this time. So 1/6 plus 4/6 is 5/6, and we just showed that. So let's do one more of these, and I think you're probably getting this, that you can just add your numerators when your denominators are the same. We're just adding our numerators because we're trying to get the same size pieces. What I would like to do, and I want a little bit more room here because I want to make sure that I have room when we do this, is I want to do one more problem adding where we are going to have a fraction greater than 1. Sorry for that. I was just taking a look at what I had written down as my next example. So let's do 5/4 plus 2/4. So 5 of these size pieces are called fourths. So 5 of them plus 2 of them is going to give me, well, 5, 6, 7. It's going to give me 7/4. So 5 plus 2 is 7. So 5/4 plus 2/4 is 7/4. So now, again, we have a fraction greater than 1. And I know that because my numerator is larger than my denominator. So let's see what we can pull out of that. Now, since my denominator is 4, I know that 4/4 is going to be equal to 1. So let's pull 4/4 out of that. So 7 minus 4 is going to leave me with 3 of those sized pieces. So again, 7/4, so 7 of those pieces minus 4 leaves me with 3. Well, again, 1/4 can just be written as 1 whole. So what I have is 1 and 3/4. And that's going to be my answer. So I can take this fraction greater than 1 and I can turn it into a mixed number. 1 whole, I can do the wholes, and I can do the fractional part of that number. Okay, so let's go ahead and let's jump right into that problem set because I think you guys are ready. That was a super quick lesson, right? Just over 13 minutes long. So let me see where I have my problems set. I know I had them sitting here waiting to go, except for now I don't see them. Oh my goodness, what did I move on top of them? Oh, here they are. I just didn't recognize them because they had green on them. Okay, so let's jump right into this. And let's take a look. So this again, right here, we are going back to subtraction. So let me just show you. We are in lesson 16. Oh my goodness. Sorry. We are in lesson 16. Oh good, I wrote the right lesson before. For a second I got nervous. Lesson 16, and we are in the problem set. We're not in the homework set, we're in the problem set. So let's go ahead and jump right into this. So over here, the first problem says 3/5 minus 1/5. And the point that they're making here is that this is just a label, fifths. So 3 of these minus 1 of these. Well, 3 minus 1 leave me with 2/5. Similarly, if I have 3 halves minus 2 halves, so 3 of those minus 2 of those, sorry about that, leaves me 1/2. And it's going to be with an F this time. So 3 minus 2 is 1, so 3 halves minus 2 halves is 1 half. Okay, so let's have fun. Let's do these. They're going to be super easy. So I have 5 sixths minus 3 sixths. So 5 of those size pieces, 5 of those pieces, minus 3 pieces is equal to 2 pieces, or 2 sixths, since the size of the pieces is 6. The label or the name is 6. Let's go for this one. 3 tenths minus 3 tenths. Oh, 3 minus 3, guys. 3 minus 3 is 0 tenths. And that's actually why I'm not going in order, because I'm going to let you guys do these, and I wanted to make sure we did that one together, because for some reason it might throw you off. Okay, 3 fourths minus 4 fourths. So, oh, sorry, it's not 3, it's 5. 5 fourths minus 4 fourths, so 5 of those size pieces minus 4 of those size pieces gives me 1 of those size pieces. So 5 minus 4 is 1, and they're all fourths. So I'm going to let you guys do this on your own. Let's go ahead and let's jump down into 3. So 3 is where we're going to end up with a fraction greater than 1, I believe, if I remember correctly when I was looking at these. So let's go into 3b, because again, I find that the examples can throw you off a little bit. So 12 sixths minus 5 sixths, well, 12 of the size pieces, of those pieces, minus 5, 12 minus 5 is going to give me 7. So I have 7 sixths. And that's a fraction greater than 1. My numerator is larger than my denominator. Now, since my denominator is 6, I know that 6 sixths is equal to 1. So I'm going to pull out a 6 sixths out of there, or 1. What about on this side? Well, 7, and I already took 6 sixths out, so 7 minus those 6 sixths leaves me, oops, I should have drawn that arrow, sorry, with 1 sixth. Couldn't help myself. So 7 minus 6 is 1. So I had 7 sixths in total. I pulled out 6 of them, put them here. That left me 1 here. And these 6 sixths are 1. So this is really 1 and 1 sixth. But where I want to really put it is I really want to put it up here. 1 and 1 sixth. So let's do another one like that. And you know what? Just to keep them apart so the page doesn't get too busy, let me see if I have another color that I can use. Nope, this one doesn't work. I'm going to grab this one. This one will work. Okay. So for this one, I have 14 eighths minus 3 eighths. So 14 minus 3 is 11. So I'm going to have 11 eighths. So 14 of this minus 3 of those gives me 11 of those. Now let's see, since these are eighths, I now know that 8 eighths is 1 whole. So let's pull out that 1 whole, or those 8 eighths. And then 11 minus those 8 eighths, because they're over here, that's going to leave me with 3 eighths. So I end up with 1 whole and 3 eighths. And that would be my answer for this one. All right, good. So I am going to let you guys do, for your work, you're going to do E and F. If you need more practice, we always have that one to go back to. So now let's switch it up and let's go back to the addition. So, and we're just going to go ahead and do the top two together. So 2 fourths plus 1 fourth leaves me, well, 2 of those plus 1 of those leaves me, or gives me 3 fourths. So now let's try this one. 4 fifths plus 3 fifths is going to give me, well, 4 plus 3 is 7. So if I have 4 of them and I add 3 of them, I get 7 of them, or 7 fifths. All right, let's look at the next one. And these are, again, pretty easy. I think you guys are going to do really well with these. If you don't, we'll go over it in our classroom. All right, so here we have 2 eighths plus 5 eighths. So 2 of those pieces plus 5 of those pieces, 2 plus 5 is 7 of those pieces. And what is their size? They are eighths. All right. So now I'm going to leave this one for you to do. But now we're going to jump over and we are going to go into problems where, again, we are going to end up with fractions greater than 1, and then we're going to want to turn them into mixed numbers. So let's take a look at this. I'm going to go back to my black pen because I think you can see it better. So we have 4/4 plus 3/4. So 4 of them plus 3 of them, well, 4 plus 3 gives you 7 of them, and we have 7/4. So again, remember that 4/4 is equal to 1. So what I want to do is I want to pull out 4/4 if I can, because I don't want to have a fraction greater than 1 where my numerator is greater than my denominator. So we're going to pull out 4/4, which is really just 1 whole. So 7 minus 4 leaves me 3/4. So 7 minus 4 is 3. So what I now have is this 4/4 becomes 1. I'm going to put it over here. And this 3/4 becomes 3/4, or stays 3/4. So I get 1 and 3/4. And I put it down here just because I didn't want to kind of cram it in up there. But these are equal to each other. Do a little equal sign. So 7/4 is the same thing as 1 and 3/4. All right. So let's take a look at another one. Let's do D together. Oh, you know what? I actually wanted to do 2 more of those together because there's an interesting one. So let's do the normal one first. Ooh, sorry. And then we'll do the interesting one. That was kind of funny. Sorry for all the noise. So let's take a look here. So here we have 7/10 plus 6/10. So if I see 7/10 plus 6/10, I can just say 7 plus 6, or 7 those size pieces, plus 6 of them. So 7 plus 6 is going to give me 13/10. So now what can I pull out of those? So I'm going to go ahead and I'm just looking around. My papers on my desk have gotten really mixed up. I don't know. Anyway, so I have 13/10. So I know that 10/10 is equal to 1 whole. So I'm going to pull 10/10 out of there. So 10/10, so 13 minus 10 leaves me 3/10. And again, I can rewrite this 10/10 as 1. This is just 1. And then I still have my 3/10. So 1 and 3/10 is going to be my answer for this one. Okay, so I wanted to do problem E with you, or letter E I should say, because it's really interesting. It's a little different. So here we have 5/6 plus 7/6. So 5 of those pieces plus 7 of them should give me 12 of those sized pieces, and they're 6. Well, I know that 6/6 is equal to 1. So let's pull out 6/6 and see what we have left. So if I do 12 of those pieces and I put 6 of them here, what will I have left? Left tells me subtract. 12 minus 6 is 6/6. Well, what do you notice? I have a whole here and I have a whole here. This is equal to 1, and this is equal to 1, and 1 plus 1 is equal to 2. So now we know that that's actually just equal to 2. So I am going to let you guys do C and F on your own. Let's take a quick peek at number 7. So still I'm using a number line to model your answer. So we do have to be comfortable with those number lines. And this is 7/4 minus 5/4, so 7 of those pieces, minus 5 of those pieces is going to give me 2/4. So now we have to put that on a number line. But what you need to realize is that 7/4 is going to be greater than 1. It's a fraction greater than 1. So let's start by making a nice easy number line. So I'm going to go ahead and draw it. I'm going to make it long enough to work with. I'm going to shift the paper in a sec. Don't worry, you'll be able to see this. And we're going to start at 0. And now I'm not going to put 1 at this end because I have a fraction greater than 1. So I'm going to go ahead and put 1 here. I'm going to put 2 there. Now, my denominator is fourths. So what I know is that each one of these wholes is being divided up or split up into, or put into fractions that are fourths large. There'd be 4 of them in here. So the denominator tells us the number of pieces that makes up a whole or what their size is. In this case, they're fourths, so there's going to be 4 of them. So let's look. 1, 2, 3, 4. Let me emphasize that 1 because that's a great benchmark. And now I cut this one up into 4 pieces as well. 1, 2, 3, 4. So I'm going to highlight our benchmarks. So 7 fourths. Let's count up. 1, 2, 3, 4, 5, 6, 7. So it's right here. And now what we have to do is, since we're subtracting, we're going that way, and we're going to go 5 fourths. So let's go ahead, and we have it. 1, 2, 3, 4, 5. So what we just did was we just subtracted 5 fourths. And what did we end up with? 1, 2 fourths. And we knew that from over there. You are going to get to do B and model that one. So I hope today's lesson was kind of easy. I hope you're really getting this idea of adding and subtracting fractions, because that's what today's lesson was. You should be comfortable using a number line, definitely. And that's it for tonight. So I will see you in our Google Classroom. You guys are doing a really great job. I'm super excited. So I will see you tomorrow bright and early. Have a great night, everybody. All right.